Hello, Marcus. We're gonna be going over the questions. Okay, so the first one is convert the point 6 2 pi over 3 into rectangular coordinates. Okay, so in order to do this, we need to convert this. So the formula is r equals, so r cosine theta, this is for x, and for y it's r sine theta. And in this case the theta is always going to be this thing, okay? So 6 cosine 2 pi over 3, and so this is our x coordinate and our y coordinate is 6 times, so you always want to solve this first, okay? If it helps you put parentheses around it. We're going to be using our unit circle for this. So sine, we'll start with cosine 2 pi theta. So 2 pi over 3 looks like this over here. So this is negative 1/2 root 3 pi over 2. So cosine 2 pi over 3, negative 1/2. And then sine is the y value. So 6 root 3 over 2. Okay, and now all we're doing is multiplying it out. So negative 6 over 2, comma 6 root 3 over 2. And you further simplify this into negative 3. And then this cancels, 3 root 3. So this would be your answer. Oh, wait, wrong one. Yeah, D, because as we're getting closer to the inside, this one says negative 3 root 3, 3. That's not the thing, because we know by solving. B is not right. It does have the right things, but it's just not the right signs, and A is just completely wrong because that's not what we're doing. Okay, number 2. The complex number negative represents negative 1/2. Okay, so a complex number negative cosine 5 pi over 3 plus I sine 5 pi over 3. Okay. Okay, and if we, wait a second, let's hide the answers. A number with a real component of negative 1 and an imaginary component of 5 pi over 3. So we know that in order to look, they're asking for the rectangular coordinates. So a number with a real component of negative 1. The real number in this case is the x value. This is x equals to real, and the y is imaginary. This is because this one has an I. It's important, it has an I over here. Okay. So a number with a real component of negative 1. So if we look at 5 pi over 3 on the table, we know 2 pi over 3 is here, and so 5 pi over 3 is plus 1 pi, so we know 5 pi over 3 is here, and so we know that if we're switching the signs on that, it's 1/2 negative root 3. It's better. Root 3 negative root 3 over 2. So a number, and because we know this is negative 1, that you're just making that negative. So is that a component of -1 with imaginary component of 5 pi over 3? No. This is what it would look like. So no. Okay, number 2. A number in the second quadrant of the complex plane. How do I? Oh, yeah. Oh, wait. Oh, I forgot. You have to multiply this by -1. This is -1, and then so because you're multiplying it by -1 over here, like this, it becomes this, okay? Because even though it's here, you still need to bring it over, so it's -1. So essentially 2 pi over 3. Okay, going over number 2, a number in the second quadrant of the complex plane. That here's 1, 2, 3, 4. So this is the original. This is the original, but because you multiply it by -1, the point would be over here. So this is in the second. It is in the second quadrant. We'll look at the other and see why they're wrong or right. A number with a positive real component and a negative imaginary component. That's wrong because again you have to multiply it by -1. A number that can be written as -1/2 negative I root 3 over 2. No, it would be -1/2 negative root 3. Oh, wait a second. I times root 3 over 2, because this is negative and this is positive, so again, they're getting the signs wrong. Okay, let's move over to number 3. Which graph represents r equals to 4 minus 4 sine theta? Okay, we'll take a look at these graphs because I don't feel like graphing them on the thing. 1 second. Okay, whatever. I think you have my toolkit. It's fine. Which graph represents 4 minus 4 sine theta? Okay, so we know that it is a heart because here I'll show you. Again, if you have my toolkit or if you have a toolkit, it should be in there. So these are the 3 things that you need to know. Okay. So if A is less than B, this is absolute value, so it doesn't matter about their sign. It's just if the number's bigger. So this one is inner loop. This one, if it's equal to, it's a heart. And if A is bigger than B, then it is a dent graph, okay? And we know that if we're looking at sine, oh damn. So we're looking at sine, it's the up or down. So 4 minus 4 sine theta, we can immediately rule out C, because this is going for cosine, and we can rule out D because we know that it's a heart and it's not an inner loop, which is this one here. I'll label this. So we know it's not an inner loop. And minus 4 sine theta, which means it's going down, which means it's negative. One way that we also know this is what is the maximum value is root a plus root b. So the maximum value would be 8, the minimum value would be 0 because root a minus root b in this case would be 4 minus 4 equals to 0. But because this is negative, it gets flipped over. So that now we know it's a, not b, because there's this part is negative. Okay, next part. Which of the following equations represents the graph below? Okay. So, oh shoot, I found it. Okay. Which of the following graphs represents the graph? So we know that for sine graphs, the petals get doubled. So let's count how many. Well, we know if the petal numbers even, they get doubled. So we'll count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 petals. So we can immediately rule out the middle two, because this is 24. That would mean it'd have 48 petals, because 24 times 2 is 48, and the second one would be 24 petals, because 12 times 2 is 24. So the next value that we have to look at is the first one. So minus 2 cosine 6 theta, and that is true because during cosine graphs, cosine graphs always start at 0. They always start at 0. Okay. The last one, sine graphs, the equation to what it starts is pi over 2r. And so in this case, it would be pi over negative 4 is what it'd start at. And this one starts at 0, so we know that is not true. So we know it is a. Okay. Okay, information about a polar function given in the table for on which intervals is the difference between f theta and the pole decreasing. So another important thing to note is that pole equals to origin, or origin or 0, 0. 0, 0 is the origin. Okay. So make it smaller. 1 second. I can't. Okay. So in this first part, it is increasing because 0 to 1.11 has a positive rate of change. What right now the difference between the function and the origin, it means that you're taking the absolute value on whether it's getting large. So if it's going from 0 to negative 1.11, or it's like negative decreasing, that still means it's getting further away from the pole. But if it's like negative, here, I'll write this down. So negative increasing and negative decreasing, and you also have positive decreasing and positive increasing. So these two are okay. This means the thing from the distance between the poles are increasing, or this is increasing to the. Geez, can I just check this? Increasing area from origin or the pole. Again, it's important to know that the origin is the pole, and then wait, I got that wrong. Wait a second. No, these are flipped. These are flipped. Okay, this is important to know. So we can tell that negative and increasing, which the pole is decreasing. So they're asking for the area between the origin and the graph, which part is it getting closer to the origin. In this case, it would be 1.11 theta to 2.09 because it is negative increasing. And if we look at this decreasing area from origin, it's negative increasing. Okay, next, in the point of r theta, what quadrant is the point? Negative r is theta plus 2. Okay, so let's draw this out. Okay, let's call this point r and theta. So right now this is our point, and then they also give us r and then, or was it negative r theta plus 2 pi. So 2 pi means it goes around twice. So it goes around once, it goes around twice, which means it'd be the same position, but because this is negative r, or you're actually, it'd be easier if this actually like this. Okay, so this is the original point, and now it goes around once and it goes around twice, but because there's a negative r right here, then it gets flipped over. So then it becomes this. So which quadrant would this be? It would be quadrant 4. So it's important to know that 2 pi goes around, 1 pi goes only halfway around, and negative changes this point over. Okay, next question. For what value does theta, the graph of r plus sine 2 theta, obtain its maximum radius? Okay. R equals to 3 plus 2 sine theta. Okay. So we're given sine. We're giving a sine graph. Okay, so now we know it's over the x-axis, or it's technically over r equals to theta over 2, but you just think of it as the x-axis. So the maximum value is root a, or absolute value of a plus absolute value of b, and we know this is positive, so it's going to go upwards. 0, this is pi, 3 pi over 2, and this is pi over 2. Okay, so the maximum value is 5, and the minimum value is absolute value of a minus absolute value of b equals to 1, and root 3, or 3 is bigger than 2. If we look at this, a is larger than b, which means it's a dent graph, right? Yeah, it's a dent graph, and so the maximum would be, okay, so we draw it like this. You don't really need to go into the specifics for the graphing for now, but the point with the maximum point would be over pi over 2. So what does it its maximum radius? 3 pi over 2, does it reach its maximum value at 3 pi over 2? No, it doesn't, so we know number 1 is wrong. Does it reach at its maximum radius negative pi? Does it? No. Negative pi would just be like this is pi, goes over, so it's 0, or 2 pi, whatever you want to call it. Does it reach the value at negative 3 pi over 2? So 3 pi over 2, if you add a negative, it goes over, so it goes around, so this goes into here. So that would be the answer, negative 3 pi over 2. It's 2 pi. Is it at 0? No. So we know it's 3 pi, negative 3 pi over 2. If that makes sense, because negative 3 pi over 2 is equal to pi over 2, and vice versa, negative pi over 2 equals to 3 pi over 2. Let r equals f theta be a polar function where f theta, okay, on which of the following intervals is f decreasing? If we look at the graph that she put down, or we can make her, actually we'll just look at this for now. I recommend going in for flex and asking for help. R equals f theta where f theta equals cosine 4 theta, which of the following intervals are decreasing? So where on this graph, where is this decreasing? Is it from 0 through pi over 2? No, because they share the same thing. Is it because pi over 2 through 3 pi over 4? Yes, because it is decreasing. 3 pi over 4 through pi? No, because that's increasing. So we know it's B. Okay, next one. Which statement best compares the graphs of R1, 3 cosine 2 theta, and R2, 3 sine 2 theta? Okay. Which statement best compares the graphs of both graphs are circles of radius of 3. So we know this is not true. These have petals because they have the stuff inside the theta and they have the r outside. They go back to, which equation is this? 1 second. Goes back to this equation. The same thing as this equation, so no, they are not circles. Okay, both graphs are roses with 2 petals. This is not true because sine. I'll show you like this. 3 cosine 2 theta. Right, this is 4 petals because if it's even, it multiplies the petals by 2. And this is the sine graph. You see, as you can see, both have 4 petals. So these both are not 2 petals. R1 represents a rose, but R2 represents a limacone. That's not true. Both are roses, as we can see. And so the process of elimination leads us with the point negative 3 pi over 2 is on the graph of R1, but not on the graph of R2. So R1 is the cosine graph. We'll take a look at the cosine graph. See, minus 3. This is minus 3. Is this pi over 2? Wait. Negative 3 pi over 2. Yeah, whatever. Process of elimination. Okay. Next. Is f increasing or decreasing on the interval of pi over 4 through pi over 2? Is it increasing? Pi over 4 through pi over 2, it is increasing. It goes from negative 2 to 0, so that's increasing. Is the distance between f theta and the pole increasing or decreasing on the interval of 0 through pi over 4? The distance between the pole, which is, again, it's the distance between the pole is increasing. The pole is 0 over 0, so distance between the pole just means as long as it's going away from the origin, so it is increasing. And is the rate of change of f faster on the interval 0 through pi over 8, or the difficult interval pi through 8 through pi over 4 faster? Okay, so I mean, they're both in between pi over 8 intervals, on which one goes larger, 0 through negative 1.41 or negative 1.41 over through negative 2. It's going to be 0 through pi through 8 over here, so it is 0 through pi through 8. Okay, is this between f theta and the pole increasing or decreasing on the interval pi over 2 theta through 3 pi over 4? So basically, in order to do this, we start at -3 over here, and you add 5 root 2 over 2 because the pi over 4, you basically multiply that by the sine and cosine of pi over 4, which pi over 4 is 2. So again, you're adding -3 plus 5 root 2 over 2, so you get to the peak point. Wait, is that the peak point? No, that's not. Wait. Okay, whatever. And then you subtract that. Okay, anyways, so is that increasing or decreasing on the interval pi over 2 through 3 pi over 4? It is the pole distance is decreasing because 2 is larger than 0.535 from 0. Okay. Find the average rate of change of f between theta pi over 4 and theta pi over 2. Okay, so pi over 2 is pi over 2, that's 2. This is pi over 2. And then pi over 4 is 0.535. And this is minus pi over 4. So you end up with 1.6. Oh, okay, well, you go do this pi over 2. And then 2 minus 0.535. 1 second. 1.465. One second. Okay, and then you get 1.865. Yeah. Okay, estimate the value of f pi over 3 using an average rate of change. Y minus 2, 1.865, x minus pi over 2. And then you simplify the equation, so y minus 2 can be simplified to pi over 3, because that's where minus 2 is this on the graph. Well, minus 2, actually, inner loop, average rate of change, pi over 3, 1 minus 2. So in order to get to minus 2, it would be on, pi over 3. And so you get this equation, y minus 2. So now that you found the x value, y minus 2 so that goes into y minus 2 equals 1.865 minus pi over 6. And then plus 2. And so then you solve, and y, you eventually get y equals 1.023. If this makes no sense to you, I don't blame you, because it barely makes sense to me. Again, these last few are graphing equations, so r equals 2 plus 4 sine theta. I'll just do this. Okay. So we have these are going to be super important for this equations. 2 plus 4 is this 2, so it'd be inner loop. The two x-intercepts would be 2 because 2 and minus 2 because 2 is over here. The maximum point would be 6 because these are the also important equations that you need to know. This is in order to solve for the maximum value and the minimum value, and then you graph like that. And then for this one, for the petals, in order to find distance in between, it's 2 pi over r. And so in this case, r equals 3, or 3, there's 3 petals. So then there's 2 pi over 3 in between, and it starts at 0. Okay, for this next one, r equals negative 2.5 sine theta. So it's negative, so which means it's not going up, it's going down, and it's a circle because there's nothing else in it. So again, the max point is over there. Okay, r equals to 4, which means it's just a circle with points of 4 all around. R equals to 4 plus cosine theta. So this is r equals to 4 plus 1 cosine. Okay, so we know that A is way bigger than B, so it is a dent graph. The maximum point is 5. The minimum point is 3. And so when that gets graphed, it looks like this. The minimum point is 3 over here. Maximum point is 5. And the last one. R equals to 4. Okay. R equals to 4 minus 4 sine theta. So theta equals to pi over 2. That's over what axis it is. It's over the x-axis. Okay, and because that it's equal, so it's a heart graph. You know it's a heart. The maximum is 4 plus 4 equals to 8. The minimum is 4 minus 4 equals to 0. And so it'll look like this. It'll look like 4 because that's over here. That'd be the y-intercepts. And then the maximum is 8 over here. The minimum is the origin. Okay, if that makes no sense, feel free to like reach out, and I can meet you at like DMark Flex or like something else. Yeah, just feel free to reach out.